Alright, this is lesson 8.4b in intermediate algebra. We're still continuing on with our function notation. We're in example 4. So we have a balloon that has the shape of a sphere, so it's like a globe or a ball, and it has a radius of 3 inches. So radius is 3 inches. Alright, use the following formulas to find the volume and surface area of the balloon. Okay, so V of R, obviously, is going to be the volume. V is for volume. And we're going to use that formula to find the volume of the balloon. And then surface area is going to be this formula, 4 pi r squared. Okay, so volume, use this one, surface area, find that one. So let's find the volume first. In order to find the volume, we're putting, instead of r right here, we're going to put a 3 in there. And then whenever we see an r, we're going to put a 3. Okay, so volume, the radius 3 is 4/3 pi times 27. 3 times 3 is 9, times 3 is 27. Then we can go ahead and cancel that with that. And we get the volume when we have a 3-inch balloon as 4 times 9 is 36 pi. And then you can multiply that times 36 times 3.14. Whoops, come on, Gary. 3.14, and we get a volume of 113, and it's in inches, so it's going to be inches cubed, cubic inches. Alright, let's look at the top and do surface area. So we're going to replace our r with 3. Wherever we see an r, we're going to put a 3. Okay, and then we just solve it. And then we're going to multiply 36 times pi again. So S of 3, the surface area, when we put 3 in, is going to be 113. But in this sense, since we're dealing with area, it's going to be square inches instead of cubic inches. And that's it for that one. Alright, let's jump to example number 5. Number 5 says, if the function of x equals 3x squared plus 2x minus 1, find f of 0. So all that means is we put a 0 in for this x, we put a 0 in for every other x. And I'd like you to do it this way. Write it out and make sure you put zeros in for every one of the x's and then go and solve. So this is going to be 0 equals negative 1. So f of 0 equals negative 1. F of 3, and again we're just going to replace all of our x's with 3's. Three times 3 is 9, 9 times 3 is 27, plus 6 minus 1 equals 32. So f of 3 equals 32. Alright, f of negative 2. Negative 2 times negative 2 is 4. So f of negative 2 equals 7. That's how I want your answers. That's how I want you to do this. Notice f of 0 is negative 1, f of 3 is 32, f of negative 2 is 7. It just looks so much nicer and neater for me to look at. So, example 6, f of x equals 4x minus 1. G of x, so they're giving you two equations. Nothing's weird. You do everything the exact same. Alright. So, if I say, what is f of negative 5? Well, what are you going to do with that? Well, since I'm dealing with an f, I'm only going to worry about this equation. This one I don't even look at. So that's going to be 4 times negative 5 minus 1. So negative 20 minus 1. So f negative 5 equals negative 21. Okay? What if I'm interested in g of negative 2? Well, that means I don't look at this one. I only look at the g one. So g of negative 2 equals 6. And that's all they want you to do. So if they give you two equations and they say a g of x or an f of x, and you look and see what they're looking for, in this one they're looking for an f of negative 5, so I use this equation, I ignore this one. Down here, g of negative 2, it has a g, so I look at this equation. This has an f, so I ignore that one. So they're just basically asking you questions to try to teach you which equation to use at which time. Alright, so let's look at something like g of a. Alright, in the past, what have you done? Whenever they've given you a g of something, you put that something in here, and solve it. That's the same thing here. We're going to put an a in for x, and I can't solve that. I'm just going to rewrite it. Okay, so there's just teaching you again that this number always gets substituted for the initial problem's variable. If I gave you a g of a plus 2, that means now whenever I look at this problem up here, whenever I see the variable, I put an a plus 2 in its place. That's all that means. So don't freak out when they give you something like this, because it doesn't really mean anything except go to the original problem and put whatever's inside that parenthesis in for the variable. And in this case, we're going to be using the x. Okay, let's keep going here. In example 7, they say, if f equals sorry about the noise, there's some kind of backhoe driving down the main road of the campground. I'm not really sure what he's doing except making noise. Okay, so here is the function. That means, this whole thing means that when I had my equation, which is not even up here, but when I put negative 2 in for x, it'll spit out a 0. My f of x will be 0. My answer will be 0. My y value will be 0. When I put in a 3, I got a negative 1. When I put in a 2, I got a 4. Okay, so what if I put in a 3? What do I get for an answer? When I put in a 3 here, I got a negative 1. When I put in a 2, I got a 4. When I put in a 7, I got a 5. And that's pretty much all it's doing in this, is they're just saying, here are the list of inputs, my first numbers, associated with my list of outputs. So if I put in an input of 2, what's my output? 4. My input function of 2 is going to give me a 4 for an answer. Alright, so last example here, which is, this is example number 8, and it says that we have f of x equals 2x squared, and g of x equals 3x minus 1. Okay, so there's our two functions there. They want to know what f g of 2 equals. Okay, so they don't even explain this, but the way you say that is f of g of 2. And when you do these, you always work on the innermost ones first and work your way out. So I'm going to look and see what g of 2 is. That means I'm going to use this equation. G of 2 equals 3 times 2 minus 1, or 6 minus 1 equals 5. So g of 2 equals 5. So now I'm going to do a substitution. I'm going to take this 5, since it equals g of 2, and put it in there. Now I have f of, instead of g of 2, I'm going to have an f of 5. What is f of 5? Take that one, and I write it as 2, and I replace my x with my 5, and I get 2 times 100, whoops, not 100, what am I doing here? 25 equals 50. Okay, so f of g of 2 equals 50. Alright, let's look at another one here. Let's look at, instead of f of g of, let's look at g of f of. Alright, make myself some room here. I'll do this in green. G of f of, what do they give us? They give us 2 there as well. Okay, so we're going to find f of 2. F of 2 is equal to 2 times, we're going to replace the x with 2, equals 2 times 4 equals 8. So f of 2 equals 8. So now whenever I see an f of 2, I'm going to put an 8 in its place. So g of 8. Now g of 8, I'm going to look at this problem up here. And instead of an x, I'm going to put an 8 in there. So I get 24 minus 1, which equals 23. So g of 8 equals 23. Or g of f of 2 equals 23. Okay? So that's what they're doing with that one. Now when you get to one like number 10 in the homework, going to be a little bit different, not much, and I've just got a minute to do this. We're given f of x equals 2x minus 5, and g of x equals x squared plus 3x plus 4. So number 10 says take f of 2 and subtract g of 3. So what we'll do is we'll take f of 2. So f of 2 equals 2 times 2 minus 5, which equals negative 1. So f of 2 equals negative 1. And in yellow, g of 3 equals 3 squared plus 3 times 3 plus 4. So this is 9 plus 9 plus 4, which equals 22. So g of 3 equals 22. So it says f of 2 minus g of 3. F of 2 is negative 1, g of 3 is 22. So negative 1 minus 22 is negative 23. So the answer to that is negative 23. So again, just to remind you, all you're doing is plugging in the number for wherever the variable shows up. So if it gives you f of 2, that means when you go back to this problem, you plug 2 in whenever you see a variable, here and here. If you've got g of 3, you go to this problem, wherever you see a variable, you put in a 3 here, a 3 here, and a 3 here, and you solve it, and that's it.